Okay, so we show another small example of BellmanFord algorithm using this directed graph. And as we already know that the number of iterations should be number of vertices minus 1. So there are 1, 2, 3 and 4 vertices. So that will be mod 4 minus 1. So that is equal to 3 iterations are necessary. Okay, 3 iterations are necessary. And now see about this. So I have also drawn the distance estimate matrix, and let's see the ages. So if we just write in the order, as we said, we can write in any order, but just for the sake of simplicity, we'll write in that order 1 to 2. This is 1, 1 to 4. Then we write from 2 we don't go anywhere, so from 3 to 2, and then the last is, so let me wipe this one. We have 3 iterations, we know that already. So this is 3 to 2 and 4 to 3. Okay, so these are the ages. Okay, list of ages. So now we have to relax in that order. So let's see, first we go for, this is a simpler graph, so we probably can do it faster. So let's see, iteration 1 is when we do 1 to 2 is okay, so let me first write it 0, infinity, infinity and infinity. We start with the node 0. So initially init, okay, initialization 1 is 0 and rest are infinity. So so then iteration 1, what it will do, 1 to 2 is 0 plus 4, so infinity change to 4. 1 to 2, this is reduced. 1 to 4, this becomes 5 because 0 plus 5 is less than infinity, so 1 to 4 also changes. And then 3 to 2, we cannot do those things at this stage. Okay, so now at the end of iteration 1, so distance estimates are 0, and then 2 is 4, and 4 is 5, and 3 is still unreachable. Okay, so this is iteration 1 done. So let's go for the iteration 2. Okay, so this is iteration 2 using black ink. So what iteration 2 does, 1 to 2, 0 to 4, it stays same. So there is no change. 1 to 4, it's 5, stays same. 3 to 2 cannot be done at this stage because 3 is distance estimate, we don't know, no change. And I mean infinity minus 10 still remains infinity. You can think about that like that way. 4 to 3 is 5 plus 3, 8. So this distance estimate changed to 8. So this one got reduced. Okay, so 4 to 3 got reduced. So we can say that 3 dot pi equal to 4, and earlier was 2 dot pi equal to 1, and 4 dot pi equal to 1 also. As the parent pointers, so at the end of iteration 2, so what we have distance estimate 1 is 0, 2 is 4, 3 is 8, and 4 is 5. Okay, so the second iteration is complete. Now we go for the third iteration. I use the purple color here. So this is like iteration 3. Okay, so iteration 3 in the same order, the ages would be relaxed. So 0 to 4, there is no change here. 0 plus 4, 0 plus 5, 5. So no change here, no change here. 3 to 2 is 8 minus 10, which is minus 2. So this one changed to minus 2. Okay, so this one got reduced. So now 2's new parent is 3. 2 dot pi changed to 3. Okay, so and then 4 to 3 is 5 plus 3, 8, which remains same, no change. So at the end of iteration 3, so the distance estimates are 1 is 0, 2 is minus 2, you see, and 3 is 8, and 4 is 5. So now this graph does it contain a negative age-weight cycle? Not really, it's not a cycle, okay? So this one does not contain. So let's see whether this is finished or not, doing a last iteration, which is iteration 4. As I said before, iteration 4 is not necessary, iteration 3 is enough. So we are just doing to verify that this is iteration 4 is not needed and the graph got maximally relaxed. So iteration 4, let's see this 1 to 4 is 5, 1 to 2 is, we have cheaper, so nothing to do in this 2. 3 to 2 is 8 minus 10 minus 2, so nothing to do here. And 4 to 3 is 5 plus 3, 8, so nothing to do here. So if you write this distance estimates, you will see that the distance estimates got sealed, so no changes, 0, minus 2, 8, and 5, okay? So no distance estimate changes. So what is the final tree then? So the final tree is like this. So 2's parent is 3. So this is like this age. 3's parent is 4. So this age, and 4's parent is 1. So this age. So this red edges show the shortest path tree edges. And these are the weight estimate of individual nodes. Okay, so that is the end of this. So I want to show you another example. Okay, so this is the new graph, and we will do the BellmanFord algorithm over this. Let's write this thing 1, 2, 3, 4, and 5. So this is the distance estimate matrix, and as you know, initially 0. Sorry, this is initialization, INIT. Okay. 0 and rest are infinity. Okay, so this is one is 0 and rest are infinity. And so the we also have to do the ages, the order of the ages. So let's write this 1, 2, this is 1, then 1, 4, then we have 2, 4, just writing in the order, 2, 4, 3, 2, and then we have 4, 3. Okay, 1, 2, 3, 4, 5 ages. 1, 2, 3, 4, 5 ages. So this is the and now we have to do the iteration 1. So how many vertices are there? 1, 2, 3, 4 vertices. So there should be 3 iterations. Okay. Let's start with the iteration 1 using the blue itself. Iteration 1, and 1 to 2 we relax, 1 to 2. So this is 0 plus 4, 4. So we change it to 4. So this is reduced. 1 to 4 is 0 plus 5, 5, which is changed to 5. So this is also reduced. The others are 3 is not reachable. So what about 2 to 4? 2 to 4. Yes, it is possible. So 4 plus 5, 9, but this is already 5, so no change. So what about 3, including 3, any distance estimate cannot be done because 3's distance estimate is 3 to 2 cannot be done at this stage. But what about 4 to 3? 4 to 3 can be done because it's 5 plus 3, 8, so this changes to 8, okay? Sorry, this is reduced. So now now let's write 1 dot pi. 1 dot pi is not necessary to write. 2 dot pi equal to from 1. 2 dot pi is 1. The parent of 2 is 1. 3 dot pi equal to 4 because 3's distance estimate got from 4. That age 3 to 4 got relaxed. 4 dot pi 4's parent is again 1. We came to 4 from 1. So that's all at this stage, and at the end of iteration 1, the distance estimates are like this. 1 is 0, 2 is 4, 3 is 8, 4 is 5. There is not a fifth one. So maybe I mistakenly wrote there's a fifth vertex, but there is no fifth vertex. Okay. So let's see now. So this is iteration 1 is done. Let's go for the iteration 2. Okay. So iteration 2, we do here. Iteration 2 says 1 to 2. 1 to 2 is 4. It's already there, so no change. 1 to 4. So this is 5, so no change. What about 2 to 4? 2 to 4 is 4 plus 5, 9. So this is cheaper, so no change. What about 3 to 2? 8 minus 10, which is minus 2. So this one changed to minus 2, you see. This one reduced. So now 2.pi got set to 3 because it's a cheaper root. Now we go again to 4 3, 4 to 3, 5 plus 3, 8. This is no change. So still there is a iteration 2, there is a change. So now in the iteration 2, what happened? What the we got at 1 distance estimate 0, for 2's distance estimate changed to minus 2. What about 3's distance estimate? It was 8 and still it is 8, and 4's distance estimate is 5. Okay. Now let's go to the third iteration, iteration 3 using purple color, iteration 3, and now you see that, sorry, iteration 3 is 1 to 2 is, we have a cheaper distance estimate, so nothing to change. 1 to 4, same. 2 to 4, now you see 2 to 4, minus 2 plus 5, that is 5 minus 2, 3, so this got changed, you see, 2 to 4 got changed. Now 4's new distance estimate is 2. You see 4's new distance estimate is 2. And 3 to 2 is 8 minus 10 minus 2. It remains same, so no change. But 4 to 3 changed from 3 plus 3, 6. So this reduced. You see 4 to 3 reduced. So 3's new distance estimate 4. Okay, this is no change. So now at the end of iteration 3, so iteration 3, what happens? You see the 1's distance estimate is 0, 2's distance estimate is minus 2, 3's distance estimate is 6, it's a change, and 4's distance estimate is 3, it's also a change, okay? So now you see here, at the end of iteration 3, these are the distance estimate by BellmanFord algorithm. This should finish, and we will still test with one last iteration, which is iteration 4. And in normal circumstances, as I told you before, iteration 4 is not necessary because there are 4 vertices, so 4 minus 1, 3 iteration should be good enough. But let's check what iteration 4 does. Iteration 4 starts with 1 to 2, 0, 4, 4, which is minus 2 is cheaper, so no change here, okay? So 1 to 4, 0 plus 5, 5, but here is a 3, so no change here. 2 to 4, now you see minus 2 and 5, 3, so no change here also. Now you see 3 to 2, 6 minus 10, which is minus 4. 6 minus 10. 6 minus 10 is minus 4, right? Yes, minus 4. So this distance estimate got changed. See, it's a 4th iteration. Still distance estimate got changed. And 4 to 3. 3 plus 3, 6. So this one does not change. See, now here in the 4th iteration, which should not be there, still we find there is a change in the weight. Do you know why? Because there is a negative age weight cycle. So the total, the cumulative, the total age weight summation of all these ages in this cycle is negative. 5 plus 3, 8. and minus 10 is minus 2. So every time you go through this cycle, every time you calculate, every time you run an algorithm, you will find at least one edge will have minus 2, two values less. So this is why this will never ever terminate, and Bellman-Ford algorithm will not work for this case which has a negative edge weight cycle. I hope you understood this video, and for any question we'll be discussing over the WebEx. Thank you.